Okay, so today we are going to discuss one important chapter, current and electricity, and this chapter is included in JAC board also, ICSE board and CBSE board also. Okay, so first we are going to define current. So current is what? It is the rate of flow of charge. So that one is called current. It is denoted by letter I, and the formula of current is charge divided by time, and in short it can be said that I is equal to Q by T. Let's understand what is current. Okay, suppose here there is one conductor. In that conductor, suppose one observer is sitting above this conductor. Okay, and he has chosen one cross sectional area, like suppose this one is a cross sectional area of the conductor, and he is observing that in 1 second or in per unit time how much current is going, how much charge is going to flow or pass through this cross section area. Let's suppose he observed that in 1 second 4 coulomb of charges passes through this cross section area. So suppose I have to calculate the current, then current is equal to, we know that Q by T. Here charge is 4 coulomb and time is 1 second. So current will come 4 coulomb per second, or we can say that 4 ampere, because coulomb per second is also called as ampere. Now SI unit of current is ampere, and 1 ampere is equal to coulomb per second. So instead of saying coulomb per second, we are saying ampere. So 1 ampere is equal to coulomb per second. Current is a scalar quantity, and there is one more another formula of finding the current. First is what? Q by T, and second one is Ne by T, where Ne is, where N is what? Number of electrons, and E is charge on electrons. So there are two formula for current. Let now discuss potential difference. Potential difference is the amount of work done per unit charge in moving a positive state charge from one point to another point. So in short, we can say that work done per unit charge, work done per unit charge is called current. Let us take one example. Suppose here there is one person who has taken one unit positive charge, or this one is also called as test charge, plus Q, and this plus Q charge has to move from A to B. So whatever work has to be done by this person, okay, in the electric field, okay, so whatever work is going to done by this person to bring this unit positive charge from A to B, so that work done WAB is equal to the WAB is equal to the potential difference between point A and B. So the formula potential difference is VA minus VB. This one is what? Potential difference between A to B. So VA minus VB is equal to WAB. WAB is work done from A to B divided by charge, whatever charge we are bringing. Okay, so WAB by Q, or the potential difference is equal to, we can say that work done by charge, and it is written as W by Q. Now SI unit of potential difference is volt. Okay, but this volt, sometimes in option they wouldn't give you volt. Okay, they will give you joule per coulomb. Okay, so this joule per coulomb is also the SI unit of potential difference, but instead of saying joule per coulomb, we say that volt. Okay, so you should remember that 1 volt is equal to 1 joule per coulomb. Now what is 1 volt? So 1 volt is defined as the potential difference between 2 points is said to be 1 volt if the work done in moving 1 coulomb of charge from one point to other point is 1 joule. So suppose we have 1 coulomb of charge, and suppose I have moved this 1 coulomb of charge from point A to B, and suppose we have done our work done 1 joule. So that time we are saying that the potential difference between A and B is 1 volt. So VA minus VB is equal to joule per coulomb, because work done we have done 1 joule and charge is 1 coulomb. So joule per coulomb it will come 1 volt. So that one is the definition of 1 volt. Now next point is resistance. So resistance is the obstruction offered to the flow of current by the conductor is called resistance. It is denoted by capital R, and the cause of resistance is what? Due to the random motion of free electrons and due to the collision of charges or ions, the free ions. We know that in every conductor there are lots of free electrons or ions. Okay, so we know that the elements composed of protons and electrons, and there is neutrons, but neutrons has no charges. Okay, so this positive charge is, and there is negative charge. This one is electrons. Okay, so all the free electrons are moving in random motion within the conductor, and while they are moving with random motion, okay, they are colliding with each other. Due to this collision, there is resistance in a conductor. So this one is the cause of resistance. Now discuss Ohm's law. So Ohm's law is the statement of Ohm's law that according to Ohm's law, the current flowing in a conductor, the current flowing in a conductor is directly proportional to the potential difference applied across its end at constant temperature. Okay, so this one is the statement of Ohm's law. Actually, Ohm's law explain about the relation between V and I, how V and I are related to each other. That can be studied by Ohm's. So Ohm's law says that I is directly proportional to V, and suppose I remove this proportionality, one constant term is come. Okay, and that constant term is R, and this R is our resistance. Okay, so R is equal to V by I. Now R is equal to VI. Suppose I put the unit of V. So unit of V is what? Volt, and unit of I is ampere. Okay, so unit of resistance is what? Volt per ampere. But we are not saying volt per ampere. Okay, instead of saying volt per ampere, we are saying ohm. So the SI unit of resistance is ohm, and 1 ohm is equal to 1 volt per ampere. In short form, it can be written like this: 1 ohm is equal to 1 volt per ampere. Now let's define 1 ohm. So 1 ohm is what? The resistance of conductor is said to be 1 ohm if 1 ampere of current flow through it when a potential difference of 1 volt is applied across the conductor. Okay, so what is the meaning of this? Suppose this one is one conductor. Okay, now in this conductor, suppose 1 ampere of current is flowing, and the potential difference between across this conductor is 1 volt. Okay, so that time we can say that this conductor has resistance 1 ohm. It is offering the resistance of 1 ohm. So this one is the definition of 1 ohm. Now next term is conductance. So conductance is, it is the reciprocal of resistance. Okay, and it is denoted by letter G, and conductance can be, formula of conductance is 1 by resistance. In short form, it can be written as G equal to 1 by R. The SI unit of conductance is, we can calculate through formula also. Okay, we know that the conductance is equal to 1 by R, and we know that what is the unit of R? It is ohm. So 1 by ohm, or we can say that per ohm. So this one is the SI unit of conductance per ohm. Previously it is said to be mho. Okay, but nowadays we are not using mho. Okay, we are saying per ohm. Now suppose in the formula of G equal to 1 by R, suppose I put the value of R, that one is V by I. So we get an expression of G. G is equal to I by V. Okay, current divided by potential difference. And there is graphical representation of this IV graph. Okay, so here I have represented this IV graph. In y-axis I have taken current, and in x-axis I have taken voltage. Okay, so suppose I draw the graph between I and V, I get one a straight line which is passing through the origin. Okay, and slope of this IV graph will give you conductance. Okay, slope is equal to I by V, or we can say delta I by delta V. So slope of this IV graph will give you conductance. So here I have written that slope of IV graph will give conductance if suppose in any conductor resistance is more. If R is more, then its conductance will be less, and if resistance is low, then its conductance will be high. Okay, because R is reciprocal to G na, that's why if R is increasing, then G is going to decrease. Now in question they will give you graph like that. There is two conductor A, there is three conductor A, B and C. Okay, now in that it is asking that in out of three conductor which conductor have more conductance. Okay, so in IV graph always remember that the conductor whose slope is more, okay, whose slope is more, that in this case A has more slope. Okay, so A has more conductance. Now second question is which wire have more resistance. So more resistance means it have less conductance. Okay, so जिसका कंडक्टेंस लो होगा उसका रेसिस्टेंस हाई होगा. ठीक है, सो यहाँ पे कंडक्टेंस किसका लो है, सी का. ओके, सो सी हैज़ मोर रेसिस्टेंस. So this one is IV graph. Okay, next we will discuss VI graph. In that one is Ohm's law graph. Okay, we will discuss that IV graph is opposite to this, sorry, VI graph is opposite to this IV graph. Okay, so now graphical representation of Ohm's law. So Ohm's law has conducted one experiment. Okay, in that experiment he has connected all the circuit like this. Okay, there is one load, and in between load there is voltmeter, and for measuring the current there is ammeter, and there is supply of current, battery, key and rheostat. Okay, so Ohm's law has studied the variation of current, okay, according to the change of voltage. Okay, so he had changed the voltage, and according to the change of voltage he had written down the changes in current. Okay, so he noticed that when he changed the voltage, okay, when he increased the voltage, current is also going to increase, and when he decreased the potential difference V, then current is also going to decrease. Okay, so let's understand it through one example. Suppose this one is number of experiment 1 2 3 4 observation. Okay, in second column there is voltmeter reading, and third column there is ammeter reading. Now suppose in first observation voltmeter is how much, 0.5 volt. So that time ammeter is reading is 0.2 ampere. Now I increase the potential difference 1 volt, then current is also 0.4 ampere. In third observation, suppose voltage is 1.5 volt. Okay, potential difference is 1.5 volt, then current reading is also increases to 0.6 ampere. Okay, so now suppose I draw the graph of this observation like Ohms has done. Okay, so suppose I want to draw this data on graph. So in x-axis I have taken current, in y-axis I have taken voltage V or potential difference V. Okay, so current is 0.2, 0.4, 0.6, 0.8 and 1 ampere. Our potential difference is 0.5, 1, 1.5, 2, 2.5. Okay, now when our potential difference is 0.5, that time current reading is 0.2, so we got 1 point here. Like that we have to draw all the point on graph. 1 volt and 0.4 ampere, 1.5 volt and 0.6 ampere, then 2 volt and 0.8 ampere. Okay, so like that we have to draw the point. When we join this point, okay, this point is going to pass through the origin, okay, and this one is a straight line. Okay, so whenever there is linear relation between two quantity, we are getting a straight line like this. Okay, so what is the meaning of this straight line? If we increase one quantity, second quantity is also going to increase. Okay, so it will show that I and V are directly proportional to each other. Now let's find the slope of this graph. So for finding the slope of graph, take any point like A, B, C, D. Choose any point. Suppose I want to choose this point C. Okay, so through C, draw one vertical line and one horizontal line. Okay, and suppose this one is our X and this one is our Y. Okay, so for slope of any line will be equal to the vertical height, that one is X, divided by horizontal length Y. Okay, so X by Y. So in this case X is what? 1.5 divided by 0.6, because this height is 1.5. See here, this one is 1.5, this, and this one is 0.6. So 15 by 6. So it will come 2.5. Okay, so slope of this line has come 2.5 volt per ampere, and I have said you that volt per ampere is nothing but what? Ohm. So 2.5 ohm. So one result we got from this graph, that whenever we are finding the slope of VI graph, okay, slope of VI graph, okay, whenever we are finding slope of VI graph, it will give what? Resistance. Okay, so through the graph we can calculate the resistance of any wire by finding its slope. Now there is one question. There is a graph, okay, in that graph there is a line of three conductor A, B, C. This one is the graph of A, B, C conductor. Now you have to tell me which conductor have more resistance. Okay, so in VI graph, always remember that the conductor whose slope is less, okay, whose slope is what? Less. In this, out of three conductor, which one has less slope? This C. C का स्लोप क्या है? कम है, ठीक है, और A का स्लोप ज़्यादा है. स्लोप कैसे देखेंगे? जैसे देखो, सपोज देयर इज टू कंडक्टर A एंड B. ओके, सो A और B में स्लोप किसका ज़्यादा है? A का स्लोप ज़्यादा और B का स्लोप क्या है? कम है. ओके, so like that we can find the slope. So in that in VI graph, the conductor whose slope is more, okay, that whose slope is more, okay, that conductor resistance is going to more, okay, and whose slope is less, that conductor resistance is going to least. Okay, so in first question it has asked that which conductor have more resistance. So which one has more slope? Yes, A has more slope. Okay, so conductor A have more resistance. Now which conductor is good conductor of electricity? So the metal which is good conductor of electricity, okay, its resistance is going to be less. Now out of these three, whose resistance is less? C. C has less slope now, so its resistance is what? Less. So what is that answer? Conductor C have less resistance. Okay, so good conductor of electricity. Okay, so this one is the Ohm's law graphical representation. Thank you.